first of all, let me share with you a notice. See, it is a notice from the authority. They have said that if you pay the tuition fee within the 30 October 2020, then you will get 20% waiver. Okay, on the September to December semester. That means this ongoing semester. Okay, but condition is that your other due should have been cleared. Okay, and another thing, if you pay the advance, okay, then you will get the 20% discount. Okay, and you can go to the campus every day 10 to 6 p.m. 10 a.m. to 6 p.m. Within this time you can get the record information from the information person. Okay, the account office, and you can use this account number. Okay, and I will share it to your messenger. Okay, so let me start the other thing. Okay, today we'll start the chapter 5, which is the reduction of multiple subsystem. Chapter 5 is reduction of multiple subsystem. Okay, we'll use this chapter. We'll start this chapter today, chapter 5. Before starting the chapter, let me share the okay, I have given to you the message in the group. Okay. Okay, let's start the reduction of the multiple subsystem. So today we will start the new chapter, which is the chapter 5, reduction of multiple subsystem. A block diagram, we have already studied a block diagram, right? A block diagram consists of many things, like these are the signals. Okay, this is the system. This thing is system, and this is the signals, input signal, output signal. Okay, this is the summing junction. This kind of thing is called the summing junction, and this kind of thing is called the pickup point. Pickup point, summing junction, these things. Okay. So signals, RS, CS, this is the system, and this is the summing junction. Components of it, okay, and this is the cascaded form. See, cascaded form. That means multiplication. Series. This is the series. Cascaded form means it is in the series. Okay. G1, G2, G3, and RS is the input, X2 is the output, and output would be G1 times RS, G1 times R, and X1, X2 into G2, X2 into G, X2 means G1R, G1R into G2, and CS finally G3 into X1. So X1 value G1, G2, RS, G1, G2, RS, and G3. Okay. So it is the cascaded form, final cascaded form. G1, G2, G3, multiply. It would be multiplied. Okay. In the cascaded form, this thing would be multiplied. What would happen in the parallel form? So remember, if we have multiple system, that means if we have multiple subsystem, then we can make a system. If those are in series, then we can make it. We can short it like this. We can reduce the subsystem. Okay, we can reduce the subsystem into in this way. Okay. Okay, so remember this thing, cascaded form. Cascaded form, we use the cascaded form here. Okay. Now what would happen if it is the parallel form? If it is in the parallel form, what would happen? Let's look at this. RS, CS. RS is the input, CS is the output. Here, G1, G2, G3, three things. G1, G2, G3, three subsystems. So first of all, X1, see, three things are in parallel. They are connected with this summing junction. They are connected with this summing junction. Okay, and what would be the output of this thing? Okay. See, parallel form. G1, G2, G3, three subsystems are connected in parallel. Here, output of this system is X1, output of this system is X2, and this one is the X3. Okay, then sum. Okay, and finally, we can reduce it to it like this. Okay. Now, what is the difference between the cascaded and parallel form? See the subsystem output. Here, these are multiplied. In the cascaded form, those are multiplied. But in the parallel form, they are not multiplied. Okay, summation. Because summation or addition. Because they came to the summing junction. That is the thing. Okay. It comes to the summing junction. That is the thing here. Okay. So I think you do understand. If you have the subsystem in parallel in series form, then you can write, you can reduce the subsystem like this way. And if you have the parallel form, then you can reduce the subsystem like this way. Plus minus depends on here. Okay, what is it? It is plus or minus. Okay, according to the symbol, you will have to write. Okay, now look at the feedback form. That is another one, feedback form. Okay, feedback. This is the input, this is the output. And see, we have some feedback. We have some feedback like this one. H1, H2, these are the feedback. See, these are in series. These are in series. So, we can write the G2, G3 and H1, H2. And we can reduce this thing also. Finally, what they did that RS input, CS output, G. This is the actuating signal, that means the error, and there is a feedback. So final equation would be like this. GS divided by 1 plus minus GS into HS. Okay, remember this one. This is the final equation. GS divided by 1 plus minus GS into HS. Okay, that is the final equation for the feedback form. See, so it is a equation. Actually, it is a equation formula you have to remember for the feedback. So if you want to reduce the feedback, a system which has the feedback, then you can use this one. Okay, you can use this formula to reduce the feedback. You can use this formula to reduce the feedback. Okay, GS divided by 1 plus minus GS into HS. Okay, so now look at the example. We have moved to the example here very quickly. So the question is, reduce the block diagram to a single transfer function. Reduce the block diagram to a single transfer function. See this example very carefully. Okay, reduce the block diagram to a single transfer function. So we have to reduce the block diagram to a single transfer function. So how to do it? Let's see. So what we can do? We can reduce G2 into G3 into G2. We can write this, and we can reduce these things. See, H1 minus H2 plus H3 minus. So we can see how we can write. See, G2 G3. We can just multiply G2 G3, and we can reduce this thing. So if I take the minus common in front of this thing, then we can write minus H1 plus H2 minus H3. Okay, and finally the equation would be like this, because we know that this thing would be multiplied. Okay, this thing would be multiplied, and here the equation 1 plus, since it is minus, so it would be 1 plus. It depends on this symbol. It is plus or minus. Okay, so from where we get this one? See here, if it is minus, then it would be plus. If it is plus, then it would be minus into GS into HS. Just means this one. See, this is the way to reduce the block diagram here. This kind of block diagram. This is a simple one, very, very simple one. Simple block diagram we can reduce. Okay. So let me clear it again. The question is reduce the block diagram to a single transfer function. So we have to reduce this block diagram to a single transfer function. So what we have H1 minus H2 plus and H3 minus. Okay, now we can write like this. We can write like this: minus H1 plus H2 minus H3. But if we take the minus common, then it would be H1 minus H2 plus H3. Okay, so they did this. So minus would come here. Minus would come here. See, minus would come here. Then it would be H1 minus H2 plus H3. and J1 will come here. It will be multiplied, and we apply the formula. Since it is minus, so it will be plus. On this one, G3 G2 multiplied by this one. Okay, so it is the way to write to reduce the block diagram. Okay, so now another thing that is also important. Say block diagram reduction by moving blocks. Block diagram reduction by moving blocks. That is another thing. Okay, see this. RS is the input, XS is another feedback, and CS is the output. Now, if I want to move this block from the right to the left, then I have to add this block here also. Actually, this is like a formula. Okay, and if I want to move the block from the left to the right, then we can write. We have to write like this. Block diagram algebra for simulation. See, we have to write like this. So that is the way. So if I want to move the block from the left to the right, then this thing will happen. And if I want to move the block from the left to the right, this is right to the left and this is left to the right, then these things should happen. Okay, this kind of thing will come. Now, see, if we have pickup points, if we have the pickup points from this left to the right to the left, then it should be like this. Or if I want to left to the right, then it should be like this. Okay, so that is the technique. So you would understand it when you do the problem. Okay, we have some examples. Just you look at those examples, then you will understand. Okay, so example C, another example is here. Reduce the system shown in the figure to a single transfer function. Reduce the system shown in the figure to a single transfer function. Okay. Oh, guys, I forget to tell you that I think your presentation is due in this term. Okay. In the final, you have to go to the presentation. You have to give a presentation. So you can select the topic presentation. We are in the chapter 5. Okay, you can check. And after that, after this chapter, we will go to the chapter 6, 7, 8. 6, 7, 8. 3 more chapter. And 9, 10. Okay. So few more, I think 4 to 5 class. Within 4 to 5 class, we will complete the syllabus. Okay. Within 4 to 5 class. In the next week, we will complete the, I think, chapter 7. Up to chapter 7, we will complete. And within this month, we will complete the whole syllabus. Okay, I hope 4 more class. After 4 more class, you'll get the full thing. Okay. So after that you can give the presentation, or we can discuss, we can review. Okay. So I need your feedback regarding these topics. And what do you know? What is the last date of your class? When your class is will end? কাদের কাদের কি আছো?
Maybe the late of November, sir. 30 of November.
10 of November.
30 of November.
13 of November.
Yes, sir.
So 13 of November. So remember, guys, 13 of November. So so we can finish the within, I think, keeping a week in hand. Okay, we can finish it in that time. So no problem. In the meantime, you make the group. Okay, you make the group. How many groups are there? Do you have any group?
No, sir.
So you can make the group, or you can give it individually, whatever you want, no problem. If you want, you can give the presentation individually, or if you want, you can make the group, maybe 2 or 3 person. Okay, 2 or 3 person group you can make. So take the preparation in the meantime. So presentation will be in the last week. Remember, presentation will be in the last week of your semester. Okay.
Hello, sir.
Last 2 class. বুঝছো? কাদের?
হ্যালো স্যার।
হ্যাঁ হ্যাঁ, হ্যালো।
স্যার প্রেজেন্টেশনটা স্যার কিভাবে দেব স্যার আমরা?
প্রেজেন্টেশন শেয়ার করবা, স্ক্রিন শেয়ার করবা, একটা বানায়া স্ক্রিন শেয়ার করবা। আমি যেভাবে বলতেছি এভাবে বলবা।
স্যার এখানে তো স্যার ল্যাপটপ দিয়ে করি না স্যার, মোবাইল দিয়ে স্যার করতেছি স্যার।
কেউ তোমাদের অন্য গ্রুপ মেম্বাররা নাই? গ্রুপ করো, যার কাছে ল্যাপটপ আছে তাকে নিয়ে গ্রুপ করো, অসুবিধা কি?
আচ্ছা
পারবা
ঠিক
না?
আছে, আলোচনা করে দেখি স্যার।
হ্যাঁ হ্যাঁ, আলোচনা করে দেখো।
আচ্ছা ঠিক আছে।
Okay. I'm not taking the quiz because I have already taken the quiz for the midterm. As well, I will have to take the quiz for the final 25 marks quiz. Okay, that's why I think it is not necessary to take another quiz here. Okay, that's why I want to give it. I want to take the presentation. I want to see your skill, presentation skill. Okay, let's go move on. Example 5.2. Reduce the system shown in the figure to a single transfer function. So look at this figure. We have to reduce this one. So first, see what we can do. See, instead of this system, we can reduce this block. Right. We can reduce this block. Then we can check this. What we can do, we can move this one here. We can move this one here. Then here 1 by G2 will come. Okay, let's see. First, move G2 to the left past the pickup point. See, at first move G2 to here. Move G2 here, then this thing will come. So, and we also reduce this one. We also reduce this one. We also reduce this one and move this one to the left. Then 1 by G2 will come here. Next thing, what we'll do, we'll reduce this one. We'll reduce this one. See, we'll reduce this one. If we move this one to the here, then one will see it is parallel, right? These are parallel. Here means 1. So if I move this one, so this one plus 1 will come, plus 1 will come. Then we can multiply this thing. We can multiply these two. In the meantime, what they did, they reduce this one also. They reduce this one also. They reduce this one Oh, no, just a thing. G1, G2, G1, G2, and this thing, G1, G2. So if I move, see, if I move this block, if I move this block to here, then here 1 by G1 will come. So 1 by G1 means H2 would be multiplied. Okay, and G1, G2. Now multiply these two and make the equation from here summing junction equations. Summing junction equations here, see, multiply it, G1, G2, G1, G2. So here from the equation that if I take the minus H1 plus H2 by G1. Okay, H1 plus H2 by G1. Then use the formula here, this one. Then again it would be multiplied.
Let B.
Final. B, this one.
Yes.
Okay, okay. Check. Here, what they did, this G1, this G1 would come here. G1 would come. So if G1 would come, then here one term will be added, which will be 1 over G1. This block will be multiplied with this one. So this thing would be H2 divided by H2 by G1. This thing would be H2 by G1 because this one moves here. Now the question will arise, why we would write like this? Then we have to move here. See, if we move the block system from left to the right, then 1 over G come to the would be multiplied in the feedback. See, it would be multiplied in the feedback. It would be multiplied in the feedback. 1 over G, 1 over G. So here the G, so this will come here, then 1 over G will be there. These things happen here in the B. See, it will come here, then G1 and G2, but H2 into 1 by G1. So H2 by G1. Okay, again here what they did, see this, it would be like, the equation would be like this, minus H1 minus H2 by G1. Now if I take the minus common, H1 plus H2 by G1. Okay, so they did this. Okay, this one, and then finally use the formula. But finally use the formula, and here the another output, it is multiplied. So final equation would be just multiply those things. Finally multiply the 2D cascaded blocks and obtain the final result. That is the final output. Okay, that is the final output of the system. Final output of the system. Now Another important thing is signal flow graph, SFG. SFG means signal flow graph. It is an alternative to block diagram. Okay, it is not similar to the block diagram. It is an alternative to the block diagram, signal flow graph. It consists of the branches and nodes. It has branches and nodes. Okay, it has branches and nodes. So you have to look at it. What is the branch and what is the nodes? See this figure. Here R1, R2, R3, C1, C2, C3, those are the nodes, and G1, G2, G3, G4, G5, G6, these are the branches. These are the branches. Okay, so here are another example. Convert the cascaded, parallel and feedback form of the block diagram. See, so they have said that convert those things into the signal flow graph. Okay, we have to convert these things into the signal flow graph, SFG, or that is called the SFG, signal flow graph. Okay, SFG, signal flow graph. So how to convert it? How to convert it to the signal flow graph? So RS, see this thing. So see how many systems are there and how many uh, signals are there. G1, G2, G3. So these signals would be converted to the node and this system would be converted to the branch. See, first thing first, what they did. At first, look at the how many signals are there. 1, 2, 3, 4. 4 signal. So you can write 4 dot, that means 4 node, and interconnect the signal codes with system branches, and then we'll interconnect them. So R, they said this not x2 or this is v2, like this. So connect it. Then that is the signal flow graph of this block diagram. Okay, so that is the conversion of the signal flow graph from the block diagram to the signal flow graph. Okay, that is the conversion. Similar thing will happen here. See this. See, this is the parallel form. How many signals are there? How many signals are there? 4 signals are there, right? So 4. RS, X1, X2, X3, and C. 1, 2, sorry, 5. 5 and connected G1, G2, G3. Then you will get this. Okay. Okay, guys, where are we? So let's look at here again. So we have the system. Okay, we have to convert it to the signal flow graph. So first of all, what we have to do, we have to convert the signals to the node. Okay, so how many signals are there? RS, X1S, X2S, X3S, and CS. So okay, we will convert this thing through the nodes. Okay, then we'll interconnect it, G1, G2, G3. Okay, we will interconnect it, G1, G2, G3. Okay, we will interconnect it, then we'll get the output. Okay, interconnect the signal nodes with system branches. Okay, so it is the output form. Convert the cascaded, parallel, and okay. Now see another thing, which is the parallel system, which is a feedback. What so far we have learned how to convert the cascaded one, how to convert the parallel one, and how to convert. Now I will see how to convert the feedback system into the signal flow graph. Feedback system into the signal flow graph. Okay. So to convert it, we have to do what we have to do. First of all, uh, see the system. So as usual, how many signals are there, and write the nodes according to this. RS, ES, and CS. RS, ES, and CS. Okay. So RS to ES, see the value. Here is no block, so it is obviously 1. And ES to CS, GS. ES to CS, GS. And CS to ES, and CS to ES, that is minus HS. Okay. So that is the weight. Okay, that is the weight of this GS and HS. Those are the weight of this branch. Note, branch, and weight. Okay, 3 things. Now look at the example. uh, it is an important one. Convert the block diagram of the figure below to a signal flow graph. Convert the block diagram of figure below to a signal flow graph. Okay. Convert the block diagram of figure below to a signal flow graph, SFG. So here, as usual, we have to see the how many signals are there. They write the signals and they can interconnect the signals nodes with the system branches, and they interconnect it. Then they will reduce it. Then they will simplify the signal flow graph. Okay, see, instead of G1, instead of this, we can write G1, only G1. Okay, other things will be as it is. Now, most important thing of this chapter is the Mason's rule. Mason's rule, a technique to reduce a signal flow graph to a single transfer function. Okay, it is a technique. It is a technique to reduce the signal flow graph to a single transfer function. That is the Mason's rule. Okay, a technique to reduce a signal flow graph to a single transfer function. It requires the application of one formula. Okay. That is the formula. GS is equal to CS by RS summation Tk into delta K divided by delta, where K is the number of forward path, Tk is the kth forward path gain, and delta is the formula 1 minus summation of loop gains plus summation of non-touching loop gains taken 2 at a time minus summation of non-touching loop gains taken 3 at a time. Delta K 1 minus loop gain which does not touch the forward path. Okay. So what are the loop gains? Say this. The product of branch gains found by traversing a path that starts at a node and ends at the same node. Okay. Loop gain. See, this is the loop, right? The product of branch gains product. See, product, that means the multiplication found by traversing a path that starts at a node and ends at the same node. So if we start from this node and if we go and move, if we come here, then a loop will be created. That is called the loop gain. So first loop gain G2 into HO. Second one, this one G4 and H2. See, start from here and come again here. Then G4 into H2. And again G4, G5, H3. G4, G5, H3. This loop. Finally, G4, G6 and H3. So 4 loops are possible here. In this example, 4 loops are possible. Non-touching loop, that means loops that do not touch, do not have any nodes in common. So this loop has no common. Non-touching loop gain, the product of loop gains from non-touching loops taken 2, 3, 4 or more at a time. So here non-touching loop 2, non-touching 1, G2H1, and this is not touched by these loops. So we will multiply all these 3. Okay, now look at this example. Question is, find the transfer function CS by RS for the signal flow graph in figure below. So you have to find the transfer function for this signal. So first of all, we have to find out the loop gain. How many loops are there? 1, 2, 3, 4 loops. Okay, 4 loops are there. Oh, again another one, the forward path. This is the forward path, right? RS to CS. This path is the forward path, and the gain G1, G2, G3, G4, G5. This is the gain of the forward path. So this is the forward path, and this is the gain of the forward path G1, G2, G3, G4, G5. See, from RS to CS, this forward path. Again, then we will find the loop. How many loops are there? Second, identify the loop gains. L1, L2, L3, and L4. So we have 4 loops. So we'll write the equation G2H1, G4H2, G7H4, and G2, G3, G4, G5, G6, G7, G8. Okay, 4 loops are there. Now, non-touching loop taken 2 at a time. Not taken 2 at a time. So 2 non-touching loop, L1, L2, L1, L3, again L2, L3. So 3 equations come here. Then non-touching loop taken 3 at a time. So L1, L2, L3, L1, L2, L3. Okay. So now from the delta, now we can find out the delta. Delta is the equation of delta is 1 minus loop gains, total loop, 4 loops are there. So write summation of loop gains plus summation of loop gains taken 2 at a time minus summation of loop gains taken 3 at a time. Non-touching loop gains taken 3 at a time. Okay, and delta K is formed by 1 minus loop does not touch forward path. So which loop does not touch the forward? This L3. L3 does not touch the forward path. So 1 minus this one, delta 1. K is the number of forward path. How many forward paths are there? One forward path. So 1 minus D7. Now I apply the formula. Now the transfer function T1 delta 1 divided by delta. So it is the equation, transfer function equation. Okay. So that is the end of this chapter. End of this chapter, chapter 5. So, so you try to understand this chapter accordingly. Check the we'll see this later. Okay, I'll show this thing later also. So this is the Mason rule. Mason rule is very important. Let me check the example again. First of all, we have to find out the forward path. We have to find out the forward path G1, G2, G3, G5. Then we have to find the loop. How many loops are there? We have to find the loops. Forward path. Then loop. Then loop gain. How many loops are there? Then the non-touching loops taken two at a time. L1, L2, L2, L3, L1, L3. Okay, non-touching loop taken two at a time. Then non-touching loop taken three at a time. L1, L2, L3. Okay, then we have to find the delta. First of all, 1 minus summation of loop gains. How many loops are there? 4 loops are there. So sum the loop gains. Then plus summation of loop gains taken 2 at a time. Then summation of loop then minus summation of loop gains taken 3 at a time. Okay, then delta k is the 1 minus the summation of non-touching loops. So how many non-touching loops are there? Only one non-touching loops are there. Okay. Then finally we'll use this formula to find out the transfer function, which is the T1 delta divided by delta. Okay. So that is the thing. We have to look at it. So that is our chapter ends. So I think